So in this video we will be learning about the memory addresses and the operations that will be performed in the memory. So memory addresses, usually by default it will be in the form of byte addressable memory, where address will be assigned for each byte locations. Okay. Similarly, there is word addresses also. It will be used in order to access the words from the memory. So in order to access the words, how it will be accessed is like it will be aligned in memory such that it begins at a byte address that is a multiple of the number of bytes in a word. So it will be beginning with a byte address that is a multiple of the number of bytes in a word. That is how a word alignment will be done. So byte addressable memory will be like successive byte location addresses will be assigned, and in case of word addressable memory means you will be retrieving data based on the word address, and how the word is being aligned, the address will be starting at a byte address that is a multiple of the number of bytes in a word. So here we can say, for example, the byte location. If we are considering some byte locations, then we can assign addresses as 0, 1, 2, 3. For each byte, addresses is being assigned. But if the word address is being considered, or word addressable memory it is being considered, then we need to check the word length. So if it is specified as 16 bits, then successive words will be located at 0, 2, 4 and 6 addresses. How it is possible? 16 bits means 1 bit is 8 bytes, so 16 bit means 2 bytes. Okay, 2 byte. So if the address it starts with 0, then the next will be 2, then again the next 4, like that it goes on. Similarly, in case of word length, if the size is length is 32 bits, then how many is the byte? 4 bytes. So the successive words will be located in the location 0, 4, 8, 12. Okay. Then this is the alignment of the words based on the word length. Now the ordering can be done, that is addresses is being assigned based on the number of bytes. So also in case of byte addressable memory, address is referred to successive byte locations. So if we are considering some 32-bit representation or 32-bit address, so in such a case if some ordering need to be followed, and two forms of ordering that is given is big endian and little endian. So this diagram what it shows is a sequence of that is a memory cells is arranged in a sequence. So downwards the address it increases starting from 0 to 0xFF. That is how many number of cells, some number of cells are there. Addresses is being given in the hexadecimal form, and downwards the address is increasing. Okay, if we are taking 1000 means downwards here it will be 1000, and downwards it moves, address will be increased 1004, like that it will be growing. Okay, then so how the word alignment is done, or how the orderliness is being given in case of the byte addressable memory. Okay, so as we all know, it will be having a 4 byte, and the most significant bit if it is given with the lower address. Okay, most significant bit if it is given with the lower address, then that arrangement is called as big endian. And if the least significant bit is given with the lower address, then that arrangement is called as the little endian. So big endian is like lower byte addresses are used for the most significant bytes of the word. Okay, so here in previous slide we have learned that a memory is there. So this is the memory that is growing downwards, and it can be addressed as a word address, and there are some cells which is allowed to store some bit of information inside this cell. It is grouped in the form of bytes. Okay, grouped in the form of bytes, like and the address is given like 0, 1, 2, 3. So the most significant byte comes over here, and the least significant byte it comes over here. And if the lower byte address is used to represent the most significant bytes, then that arrangement is called as the big endian assignment. And if the least significant byte is given with the lower byte addresses, then that arrangement it will be called as the little endian assignment. Okay, so here inside the cells it is called as the byte addresses, and outside here what is the address that is given, that will be used to represent the word addresses. Now we can consider some problems. First question is like a memory has a 32-bit address and is a byte addressable. What is the size of the memory? So here something that need to be noted is like during the first class of memory, that is when we started studying this memory concept, we have learned about the bit and bytes. So in that we have learned 1 bit is equal to 8 bytes, and if it is given like for a memory, if it consists of k bit address, then it will be having 2 raised to k words, and also it will be having 2 raised to k bytes in case of byte addressable. Okay, in case of byte addressable memory, you will be having 2 raised to k bytes and 2 raised to k words if it is a word addressable memory. So starting with the problem, a memory has 32-bit address and it is byte addressable. What is the size of the memory? So here it is 32-bit address, so the number of bytes will be like 2 raised to 32. Then second is memory has 24-bit address and is word addressable with a word length of 32 bits. So word length is also given and it is word addressable. So what is the size of the memory in bytes? So you need to calculate the size of the memory in bytes. So if it is that is 24-bit address, means for a word addressable thing, a memory, you will be having 2 raised to k words, which means that 2 raised to 24 words is there, provided each word is having how many bits of length? It is a word addressable memory, and it is having how many bits of length? 32 bits, which means that 4 bytes. So you need to convert this 2 raised to 24 into the number of bytes. So that is like 32 bits. 32 bits is there, which means 2 raised to 2, which is equal to 4 bytes. So totally you will be having 2 raised to 26 bytes. Okay. Then third one, a memory has 16-bit address and is byte addressable. 16-bit address and is byte addressable. So word length is given as 32 bits. How many words can we store in such a memory? So here we need to find the number of words. So for that purpose, so what is 2 raised to 16-bit address, and it is byte addressable, which means that you will be having 2 raised to 16 bytes. Okay, now word length is 32 bits. So you are having some bytes and that need to be converted to words. So for that, what you need to do, you need to divide it by 4 bytes, that is 2 raised to 2, which is equal to 2 raised to 16 by 2 raised to 2. What you will be getting? 2 raised to 14. Okay, so 2 raised to 14 words we will be able to store in this case. So solution is also given here. Just a conversion is being done. That is 2 raised to 32 you will be getting. You know that 2 raised to 30 is 1 gigabyte, and when you do this calculation, it will be like 4G gigabytes. Similar is the case here. It is done 64 megabytes you will be getting as answer, where 1 megabyte is equal to 2 raised to 20 bytes. And here also you will be getting the answer as 2 raised to 14 word. So where when it is converted in the form of kilo K, that is 16K words, you will be getting the answer, where 1K is equal to 2 raised to 10. And different operations that is performed in memory, that is load and store operations. Load is like you will be reading some content from the memory, and store is like writing the content to the memory. So in order to perform this operation, what is the thing that will be given? That is, address will be placed in MAR. Read signal will be initiated, like read the content from the memory. So the content that is read will be placed in MDR, that is memory data register. In such cases, you will be able to use the registers also. While performing this operation, the copying the content of the memory to some registers, it is being done. In such cases, the memory content also, it doesn't get changed. But in the case of the second operation, that is store operation, what happens is the content of the memory, it is overwritten. So how this can be performed? Address will be placed in the memory address register and data will be placed in the memory data register. Control unit, it will be initiating a write control signal. Okay, so in order to perform this operation, data can be taken from the registers also. Okay, from the registers also you will be able to write to the memory. So this is the case with the memory address and the different memory operations. So next video you will be learning about the different instructions and its format that is being used to perform any task.